Welcome to EDU World Space.
In this question, which is question number 107 of chapter 1, Intro to Chemistry, Structure and Properties, we've been told that a sample, which is an alloy, is composed of gold and palladium, and the total mass of this sample is 67.2 grams. And the number of atoms in this sample is 2.49 times 10 to the power 23. And we've been asked to find the percent composition by mass of, I guess, either one of these components, right? So the first thing you want to do is to determine what the molar mass of these two elements are. So a quick look at the periodic table gives that suggests that the molar mass of gold is 197. It's actually 196.97, but I've approximated here as 197. And for palladium is around 106. So assuming we call or we denote X to be the moles of gold and Y to be the moles of palladium, we can actually write an expression by combining the moles and the molar mass to give the mass, right? Because the mole is equal to the mass over the molar mass. So the mass is essentially the moles times the molar mass, right? So essentially, if we multiply this moles by the molar mass, which has units grams per mole, we would get the mass. So the first thing we should be writing this for this question is that X, right, which X is the moles of gold, right, times the molar mass, which is 196.97. I'm going to ignore the units here for the final answer. And we add that to the mass of palladium. And the mass of the palladium is going to be the moles of palladium times the molar mass. So you have the moles times molar mass, which is 106.42. So I'm using the exact molar mass that's been recorded in the periodic table. And like I said, I'm going to ignore the units here until the final answer. So this is the total mass, and that has been given. This would give us the total mass, and that is 67.2. Right? So obviously grams. Right? So this is one component of the question. So this is one expression that you can write given the information that's been provided. The second part is that you have the number of atoms in this molecule, right? You can write an expression that can yield the number of moles, because we know that every atom has 6.02 times 10 to the power 23 molecules, right? That's essentially 1 mole of a substance, right? So if we have the number of atoms here, so 2.49, if we divide that by the total amount of atoms that each sample should have, we should get the number of moles in this sample, right? So when you solve for this, you're going to end up with 0.414, right? And this is a total number of moles in our sample, because we know that amount of atoms that's present. When we divide that by Avogadro's number, we're going to get the number of moles. But keep in mind that this number of moles is the sum of the number of moles for gold and palladium, right? So it's x plus y. So essentially, we can say that y, which is the number of moles of palladium, is 0.414 minus x, right? So that's just writing this expression in terms of x. So y equals 0.414 minus x. So now we can substitute this into our equation here. So essentially what we have is 196.97 x. We're going to keep x variable same and just substitute y with 0.414 minus x plus 0.414 minus x. That has to be multiplied by 106.42, and that should give us our total mass, which is 67.2. Right, and this is a simple arithmetic that can be solved. And when I solve it, I get x to be equal to 0.255. Right, so now that's the moles of gold in this sample. To find y, all we have to do, the moles of palladium, we just have to substitute 0.255 in place of x, and that's what y is going to give us. So in order to find the mass, because you're supposed to find the percent composition by mass, all we have to do is the mass of gold, right? So the mass of gold is going to be the moles times the molar mass, which is 0.2, the moles which we just calculated, 0.255 times the molar mass, here 196.97, and this gives approximately 50.2 grams. So now we can find the percent composition, that's the mass composition of gold in the alloy, right? So the mass composition, right? So the percent mass by gold is going to be equal to the mass that we've just calculated, 50.2 grams, divided by the total mass, which is 67.2 grams, times 100. And this ends up being approximately 74.7%, right? So that's a percent symbol here, right? So so approximately, so we know that the percent mass of gold is around 75%. So then for palladium, it's just 100 minus that, and that is going to be 25, roughly 25%, 25.3 to be exact. So that's our final result.